And so I'd just like to maybe just do a quick intro, a couple of lines about who you are and what you do, would be appreciated. We do this monthly call, just very informally. Usually it's either just a few presentations or problem solving within the community of food-related ontologies, and it's not limited to just obofoundry ontologies such as foodon. So we certainly welcome other people to show up and pop in and out as your interest arises. So first, Fidel, would you like to just tell us who you are? And
good morning. I saw that it's 9 p.m. Are you getting me? Okay, yeah, then good morning. I saw that it's 9 p.m. there, but here in Cameroon it's 5 p.m. It's 9 a.m. there, but here is 5 p.m.
Okay.
Yeah, I'm Fidel Jomekon Azanzi. I am lecturer here at the University of Yaoundé 1 in Cameroon. I'm working in the domain of knowledge engineering. This is my domain of research. I'm working on food processing in general. Oh, how food data can be collected, how they can be processed, how they can be used to solve real world problems. And currently, I'm working with ORKG, Open Resource Knowledge Graph, to compare papers on food to compare research papers on food. Then I start my work with food ontologies. I compare some papers. I share it with the group last time. And now I'm also working on food composition tables and application of food ontology and food knowledge graph in real world application, the use of food ontology and food knowledge graph in real world application like food recommendation, ingredient recommendation, and so on and so forth. Then globally.
Great, that's right down our alley for sure. Okay, Ida, would you like to just say a few sentences about what you're up to?
Me?
Yeah.
Hi everyone. I'm very interested in these topics because of my expertise in dietary assessment. So,
okay.
Currently, I'm an independent researcher, as I'm retired, but it's in my interest.
Okay. Well,
thank you for your initiative.
You bet. Hopefully we're a good resource, and let us know what you might need.
Here is 6 p.m. in Rome, in Tuscany, in Italy.
Oh.
I am Magali, and I am in France, so I'm not so far from you, and it's 6 p.m. too.
Yes.
Nice to meet you.
Okay, Andreas, I don't recognize that name.
Hi, I'm a student. Can you hear me?
Yeah.
I'm a student at the University of Bremen, and I got invited by Michaela because we are working on classifying recipes for my bachelor thesis.
Okay, great. Gotcha.
And it's 6 p.m. in Germany too.
Gotcha. And the other two new names, sort of, I know Elizabeth or no, but maybe you would like to give a little intro too. And the mute button.
Yeah, I just saw that. So I'm Elisabeth Arnaud. I'm connecting today because I want to know more about the topic you're presenting. Usually I try to follow also the JFOW presentations. I work for the International Research Institution on Agriculture, and I'm leading several ontology projects, and recently one for food products. So that's why I'm here.
Okay.
Nice to meet you all.
Great. And AKM, if you'd like to introduce yourself.
So can you hear me?
Yep.
Great. Okay, I'm Anne-Catherine. I'm also a student of, a bachelor student of Michaela.
Okay.
And so I just wanted to listen to this.
Great. All right, so let's get started. Michaela, you've got some very interesting topic material here, and who better to introduce it but yourself? So please launch into what you like to present.
Okay, thank you. Okay, so sorry in advance for everyone who's too much into food. I will start with something else, but I hope it's interesting. Can you see my screen?
Let's see. My computer's just showing one screen, but that could be just me. Do other people see screen share?
It's okay.
Yes, it's okay.
Yeah.
Okay.
Okay, so I will talk about how I'm actually deploying knowledge graphs in different environments, and this in 2 example projects I'm working in, the Knowledge for Retail project and the EASE project. EASE stands for Everyday Activity, Science and Engineering. Yeah, when we want to teach autonomous robots to cook, to set the table, to clean the table, and support people in their kitchens and living rooms and household environments. Okay, so first of all, this is me. I'm a research associate at the Institute of Artificial Intelligence, and my research interests are in the fields of web knowledge acquisition, knowledge representation, and augmented reality applications. Okay, I will talk about the Knowledge for Retail project. An example knowledge graph I created, the non-food knowledge graph, and how it can be deployed in different applications in the Knowledge for Retail project and in the EASE project. Also, I will go over how I plan on deploying the food ontology. So the idea in the Knowledge for Retail project is that we digitize stationary retail environments for various applications. Therefore, we have a robot scanning a retail store and creating a semantic environment map called scene graph of the store. Basically, this is like an inventory. So we have an ontology where we have information like a certain product has a GTIN. This is the barcode encoded in the price tag. Its location on a shelf and shelf layer. Also, we have detailed position information like the coordinates. And we have a stock and a price, which is also available at the price tag. And this is connected to a symbolic knowledge base, like combined and linked ontologies created from enterprise databases like ERP systems, where you can get additional product information like its brand or a planned stock. And of course, web information like its classification or product information like a label, a brand classification, ingredients, and so on. So that this is the workflow of the project. We have a robot creating stock taking. Then we have the semantic store map, which can be accessed online in an open EASE. That's the name of the web interface. And it can be used in various applications. I want to show you a video for this. First, this is how the robot performs stock taking to create a semantic environment map. So you can see that he scans every shelf, then every shelf layer, like every shelf can have different amount of layers. Then all products that stand next to each other, and then it actually counts all subsequent products behind each other. And this is done for all shelves to create a semantic environment map, which basically is a semantic digital twin of the store.
Can I just interject one question?
Yeah.
If you wanted to go a little bit more low tech, could you just be taking pictures of the store shelves and amalgamate them and be able to then jump in and use your software? Or is the robot really doing some specific things here?
Well, you could probably do it, yes. But we also use the RGB depth sensor for counting the products. So I doubt that would work, but for the general layout, it might be okay.
Okay, just curious.
Yeah. Actually, we don't have special sensors. It's really simple cameras that can be used. Yeah, we can ask the knowledge base where a certain product is, or where empty facings are that need to be restocked, or a favorite query, where are dangerous products that are reachable by kids. Yeah, and this can actually be done in the web. And then we can also spawn it in virtual reality and go shopping in the virtual environment.
I'm getting up to speed with your jargon. You just said spawn this into virtual reality. Is that what I heard?
Yes.
All right. We're talking hardcore here.
Okay. And we can analyze motions, which is actually what we're going to use to teach robots to perform actions. Okay. Oh, do we have a shelf replenishment? This is not, right now, this is more a demonstration how this can be done. Of course, we have very tricky objects in the store. Not every object can be grasped by a robot by now, especially not with this gripper. But it can be performed. And yeah, we have a startup that's actually doing, the robot looks different now. This was the first version, but the idea is that the robots scan the stores every night to have digital twin stores. And you can, well, actually, I'm jumping to the next video now. So, okay, we have a little short version of this again. Sorry for that. I didn't have time to cut the video for you.
I'm just curious, why did the previous robot not hack it? Why did you have to upgrade to robot number 2?
Well, if you want to be a startup, you have to be cost sensitive, right? So the previous robot was built by us, our institute. And if you want to sell, I don't know, 1 million robots, and especially like in retail stores, they will not spend so much money on robots. So this one is a lean version. It only has a camera going up and down. Okay, so here you can actually see how to query the website for executed actions. You can visualize it. And you can ask, again, which products need to be restocked, or where can I find products that are conform with my allergy. Oh, this is really fast, but this is actually the augmented reality work that I'm doing. So you can set a preference for a store. You only want eco-friendly products or vegan products, and then you get an overlay. You can also ask for brands of the product and where they are. Our goal is to also have collaborating robots for click and collect tasks. So on the left side here, you have a robot with a cart bringing the products, and the other products performing the pick and place motions. And this was also a student work of mine, where you can ask a robot for the destination of a product, and it's driving there and showing you where it is. A logistics example, you can ask for how many products need to be reordered and when they need to be reordered. You can compare the layout of different stores and so on. So it's a cool project. And let's continue here. So what I'm actually doing in this project, I created this non-food knowledge graph because I wanted to get non-food product information from the internet, and well, there were basically none. So my idea was to create a knowledge graph with product information. So I created a taxonomy, which is based on different online store sitemaps from Aldi and from other retail stores. And so it's a merge ontology that's generalized to different stores. It's then linked to definitions in the product types ontology and Wikidata. Of course, it also links to the location information from the digital twin and the agent, so it can be used in applications. It has dimension information like the amount, height of products. It links brand to business entity information, and reuses the good relations vocabulary here. It includes packaging and recycling information, label information, nutrition information, and here we come to the food part. It links to the nutrition information actually comes from the FDC website, and then we link food to nutrition information, and the food information links to the food ontology and the food knowledge graph. We also have non-food ingredients and allergens and hazard information, which links to the Chibi ontology. And all this can be used in cool applications. Oops. Like routing to search product locations. I have developed some applications on the HoloLens and on the smartphone where you can, similar to the robot, ask where's detergent or where's the cheapest toothpaste containing only natural ingredients. Some cool queries. And yeah, you're routed to the product destination here. You also get customer shopping assistance. You've already seen the robot doing this. Also, again, compared to other applications in AR, of course, this has been done before, but you probably cannot ask queries that are so complex. We've performed this on different robots, so it's actually agent independent. Then you have seen this demo. We also have a smartphone demo, which I can show you. Sorry. So where a product is recognized, you get labels or information here, then the name, ingredients, and you can put it into your shopping basket. Here you actually have a label, but of course this can be personalized. Okay. I've also worked on action modeling, and so this is interesting to some other folks, I guess. So, for example, here we the cutting action. We do a task segmentation and segment it into the approach, lower, and lift sub-actions, which then have image schematic representations. So so the thing is, we want to have to model this situation before pushing down the knife through a bread or to cut something. Some states have to be satisfied, and after cutting, some other states have to be satisfied, and this can actually be used for failure handling. And through logging actions and like doing narrative analysis of actions, we can also visualize actions. So we can see where did customers walk while shopping for something, for example. Okay, in the East project, we have a little different problem here. We have a very open environment. We interact with the humans. We have missing knowledge about basic semantic relations. And one possible solution is to connect to the semantic web, reuse many existing knowledge sources, and make robots understand this. So my idea here was to have the belief state. So this is like the scene graph we've seen in the beginning. We have object information with a position and a barcode, might be, to link it to this product taxonomy in the non-food knowledge graph, where you can, this barcode is a milk, which is a drink, and then we link it back to the action model of an agent and know that a drink can be used for adding a drinking ingredient. And we know that this object it perceived can be used to perform a specific action. Of course, this can be expanded to other semantic web sources. We can link to Wikidata. We can link to recipes, concepts from ConceptNet, and get information from Open Food Facts, for example, which I've done here. So, for example, we have a recipe recommender similar to the food knowledge graph, but we can actually scan some leftover products on the our kitchen table, scan the barcodes, and we get recommended some recipes to be cooked with these products. Or we can have online shopping assistance with the nutritional information. So we can search for products that contain certain nutrients. Here it's a vitamin C. And we can actually see if the product is available in the store next door. Okay, currently I'm developing this recipe ontology out of the 1 million recipe data set. And I'm planning on an application for hands-free cooking, where you set on smart glasses and based on the time and your preferences, you get a recipe recommended and can choose the recipe, and it's going to be visualized over your countertop, and then you can cook without needing your hands to do some like touching the smartphone or something. Also, we're working on learning action parameterization from WikiHow instructions. How pouring can be performed, but also how actions can be classified. For example, like what is the difference between draining and pouring? Do different objects need to be involved here, but also dicing and cutting? What I'm focusing on also is to link object information to agent information in Wikidata. So we can already infer that a cutting action needs a gripper and a hand, sorry, and a cuttable object, and probably also a cutter object in order to be performed. And if you close the loop and have the dispositions of objects that they are cuttable or can be used to cut something, we can actually close the loop and use the information here. Okay, that was a little intro to what I'm doing. Any questions?
Wow. Obviously, we can all see the need for ontologies to fulfill your voracious appetite for the connection between robots and retail environments and the complexity of robotics. Lots of questions on the floor. I think, Matthew, you kind of started off with some. Would you like to begin? And your sound might not be on. Matthew?
Can you hear me now?
Yes.
Okay. Sorry about that. Really, really great. Stoked to see the Internet of Food materializing as a mashup between the semantic web of food and IoT for food, which it seems like you're bringing that out, which is something I've been thinking about for a very long time. So that makes me really, really happy. I'm wondering, you've got all of these, I think your slide said non-food KG aspects. You've got different vocabularies in there, good relations, you've got open food facts, you've got food on, and a lot of these various vocabularies are representing things in different ways with different hierarchies. How are you going about matching those things? And once you do that, are you making that source code available to the world so that there are these crosswalks? And so a two-part question. How are you doing that? And then what portion of what you're doing is open source, or at least open to potential collaborators?
Okay, I'm starting with the second part.
Sure.
It actually is openly available. I have different access points where you can query the information, you can download the ontologies and try it out. I also have a Sparkly's website for people who are not familiar with SparkQL. But yeah, regarding the ontology alignment, I think it works. I have to say that I'm trying to align as little as needs to be, and for these purposes, it is okay. I think if some people look at it, they will say, oh, these standards are different, like, you know, even only looking at the example that some, like the food knowledge graph, they use instances for an apple or, you know, a pepper or something. And I use classes and have instances for the actual products. But I use both in my ontologies, which some theoretical people might say, well, you have to remodel it or something. But I think that for me, the standard of linking as much knowledge as possible is higher than of aligning the ontologies. Does that answer your question? Somehow?
Kind of. I'm just wondering how you operationalize that. Like if you go from accessing something in food on, how do you get the parallel thing over in Open Food Facts? What's, and do you have, and that's the level of, I guess, source code. Do you do that real time? Have you pre-computed those bridges? Or you have some kind of fuzzy match that's real time, like, and
yes,
yeah.
Okay. Well, some of it is, or most of it is actually pre-computed, yes. And basically, the upper ontologies are pretty similar. If you so it's not too hard to have different concepts here. And then, of course, I reuse some of this great work from Tarini, who's doing the word2vec on linking.
Nice.
Which helped me a lot to link the ontologies. Yes.
My guess is you're not relying on OWL reasoning much. Most of your work is done through querying.
Only a little. I mean, the ontologies tend to get really huge then.
Yeah. Okay. Anything else, Matthew? Or
no. Great, thank you. And if you could drop the code base or a link to it or something like that in the chat, and that would be helpful.
Yeah, sure. Thank you. We can also have some future discussions, of course.
Yeah, great. Yeah.
I see a question from Ada. Do you want to pitch that directly? Or I'll read it out.
For me, just a curiosity about this very interesting thing, and that is the robot scanning. And I was wondering if images, sorry, I don't know the pronunciation, well, are considered in the scanning. I mean, Nutri-Score, traffic light, and also for fresh food, how is considered in this scanning activity. Thank you very much for the presentation. Very nice.
Thank you. Yes, we are working on perception. Of course, you need a little better perception to perceive fresh foods like an apple, or at first I was only focusing on the easier products with a barcode. We're also looking at some other areas where probably going to have some really different environments. We're going to be operating in, like in a hospital or in a bookstore. Right there you have even other objects. So yeah, we are looking into this.
Right. You actually kind of started out with a hard problem space of the food space. Other objects keep their form and have little barcodes on them, right? A little more easy visually to recognize.
Yes.
Thank you very much.
Okay. Any other questions at the moment? Michaela. Yes, Magali.
Yes, sorry, I'm not so easy to. It is not so easy to speak in English, but I found your presentation very nice, and but I'm afraid I have not completely understood what you explained about the linking, but that's not my specialty. I'm more in a food process engineer, but I am dealing with ontology currently, and mainly I'm doing some application, not modeling, but application. And I was interested to know how do you link your EASE project. You mentioned the ERN codes to link object and product. And as far as I know, these codes are not permanent ID, and they may vary across countries. So I wonder how to deal with this aspect.
Well, they are supposed to be unique. Actually, this is a problem. Also, if you have really old products. So, for example, if we have demonstration products from 8 years ago. There's no information available online anymore because they are discontinued probably, and they have new codes here. And actually, it's G10 codes.
Yes.
Yeah.
GS1 or G10.
Yes. But with the current stock of retail stores, it's usually available, and you can easily query it in online stores. For example.
I think it is a question of matching with, it is not a unique key, it is an aggregation of time and location to identify the product properly, I think. But yes, as you mentioned, if you are at the right time, you can access the information, but it was a story of
yes, okay,
of permanent ID, and so the management of the EIN codes are depending on the firms, on the society, the commercial society, and so it may vary, but it is a key to link products, especially with open food facts. But yes, it is still an issue.
Yes,
I think.
And we'll
That's
be
nice.
We'll be interested in that from the food on perspective, in that one of our objectives is to at least do GS1 mapping of BRIC codes in the next year or so. So whatever you guys can feed to us about the link to EIN would be great. Okay. I think Tarini and I would like to do a bit of a segue into our own work on the process modeling side, which actually really it hopefully aligns with your robotics stuff. So we'll have to take a closer look at that. I'll just say that the food process ontology requirements paper that we submitted to the software, the Semantic Web Journal, was just accepted a couple of days ago, finally. So I'll just pop a link into that right here. This is not the final version of the paper. I'll work on that and get that out. But that's sort of the technical OBO Foundry needs list for doing process modeling that we can perceive. But that left open this whole subject of how to organize or categorize the food process hierarchy. And that took us actually into the more general space of any kind of process. So Tarini and I have prepared a little slideshow to show where we're at and some tentative definitions that we would like feedback on before we cement them into food on. And I guess just a preliminary comment is that a number of these classes are actually super general. They don't just apply to food, and that raises the question of which ontology they should really be destined in ultimately. But for now, we'll start with the food on side. Yeah, so Tarini, would you like to take it away? And thank you so much. Thank you so much, Michaela, for that perfect presentation, kind of pointing to the future where all this semantic stuff is headed. So over to you, Tarini.
Yeah, thanks. Yeah, and since Damien and I both worked on it, I think we will each add to every slide as we sort of go along. So this was in a very kind of basic way, fundamental way. There's two reasons for processing or cooking a food. And one is why you want to do it. And the why could be food safety, nutrition, sensory properties, taste, flavor, texture, preservation. So, the why is very broad, and it would be the objective. And then how you do it, how is the mechanism, what kind of energy you use, whether it's a force, a directed force, whether it's adding heat, taking away heat, is the how, that's the mechanism. And what this means is very again, broadly, and Damien and I spent a lot of work, going down, bottom up, to see whether this very overarching, it almost sounds too general, but to basically see if it can hold up to all the different classes you have underneath. And at least to the extent to which we explored it, we still find this quite robust. It doesn't mean that there aren't more aspects to it, but we thought whatever else gets added on, these two seem like two very upper level classes to have. And what this means is that one objective can be satisfied by different mechanisms, and also some mechanism can be applied to achieve also many different objectives. So this, this way of these two high-level classes is not setting anything in stone that, if you want to emulsify, you have to only do it this way. And if you apply heat, for instance, like mechanism, simple example, how much heat you apply to what temperature you apply can take you from simply just warming something to boiling it. So this slide, I will just explain a little bit more about the objective, and then Damien can add a little bit anyway, but especially to the OB classes because he's more familiar with this than I am. So the objective takes time to happen, and it's a combination of the material plus the mechanism, and different material, same mechanism will lead to a different objective. The output is measured to see if it meets the objectives unless the time is preset. So if you were boiling something, and it always boils in 5 minutes, and in 5 minutes, it's boiled. Otherwise, of course, you have to measure it to see. It might take longer, it might take less. And the equipment is not included here. So in that second bullet point there, material plus mechanism, it's about the time and the specification. Of course, the time there depends on the equipment. If you had a pressure cooker, it would take less time. But anyway, we'll talk about mechanism separately. So this is not to get into that, but it's important that we never really went into the equipment. So, the how would also, you could also say is the equipment. So that's another layer, but I mean, equipment could be its own ontology as well. So we know we're not addressing everything, but we wanted to be clear about what we did do and what we understand could be a separate ontology, but connects here. So that's all I have to say at this point.
Yeah,
Damien?
I would just add that it's sort of shifting sands in the OBO Foundry a little bit. OBO Foundry is dedicated to the life sciences, so I never really had much of a focus on equipment per se. OB has its device hierarchy, which is where one would normally put medical devices, because that's OB's domain. But then the expectation would be if we had food-specific equipment, that could go in food under devices. On the other hand, a lot of this stuff is actually pertinent to general laboratory procedure and robotics in general. So OB, the life sciences haven't really developed a consistent approach to that. And here, plan process, an OB term, is actually probably going to shift to a more general mid-tier ontology called COB that OBO Foundry is introducing to collect the commonly used terms. So just a heads up on that.
Okay. So a little bit more look at the how, the objectives. So again, we spent a lot of time thinking about this, and we didn't want to add food specificity like right on the top. We wanted to really just add it as we go, lower down in the classes, where like clearly the reason that you do something, the objective is very food specific. And of course, we wanted to do a food processing ontology. So we have to get down to the food level, but we tried to see what could be kept general. So material is not necessarily food. For example, a paint can be emulsified. And then we spent a lot of time thinking about the objective types. And even when it relates to food, is the obvious one is how you want to change the material, that, to eat it, you want to make it soft at least, and then of course, make it crispy or whatever else is delicious. But there's also efficiency, how, and maybe this is also important for like robotics, like making trade-offs like one does in the kitchen, how much time you want to use or power usage. And so this could be another objective type. Applies to food, but not necessarily. And then when we get down here, so again, I'm sure there's like lots of questions, and it's really not possible in the remaining 10 minutes to explain a lot about all the different classes. I'm talking now at this like tier 4 level. But it was important just here that when we talk about consumption, and again, I think the nomenclature, we're still like really thinking about it. And so if there's any suggestions for nomenclature, like please don't hold back. But for consumption, we realized that there's like, at least there's these 3, and there could be more, that nutrition or food safety especially, it needs to be like much more precise if you're going to make a claim like that. So at this point, we're not really exploring food safety and looking at the organoleptic. So we build out this for organoleptic. But again, all these are just opportunities to collaborate and work together. Can I move on to the next one, Damien?
Yeah.
Okay. So I think there was, yeah, okay, so a little bit more here. And in the consumption class, of course, at that point, it is food specific. And as you go kind of lower down, you start getting more specific. Of course, the classes will have multiple parents. You would do like a homogenization process, but you would also achieve, some sort of a texture. And as you, of course, you go lower down, then the qualities or the roles that are conferred to the materials and the foods will become more specific. Like, for instance, homogenization or emulsification, depending on what you're emulsifying, the effect may not always be like a salad dressing or something. It could be something else. So I think that idea, so that notion of objective is like really connected to a quality or a role or a function. And again, we thought like quite a lot about this. So we tried very hard to like disambiguate the meanings of all of these terms. And so I think like this whole, what we created so far was a process, just to explain to you how we did this, was we did a lot like top down, bottom up, and tried to see if there was a kind of agreement. So we really challenged this quite a bit. Damien?
Yep.
Sorry.
Nope, that's nothing more to add there.
Okay. Yeah. And I think the mechanism class so far is like, you know, a little bit like less developed if you just think about the objective slide before this. And I guess this is like, we really thought a lot about this, that there are no specifics. So heating, again, this is like an idea that we haven't like completely closed our, you know, our sort of our discussion, our thought process on is how specific to make it. You know, should heating be, you know, boiling, or, you know, is a term like boiling more associated with like a boiled food rather than just having like boiling, simmering. So at what point, I mean, the mechanism does not, like the first sentence there is it suggests that there's a relative change in the material. And it's not including a specific of how long you're doing it for, what temperature you're reaching. And there could be other specifics. I mean, heating up, this makes sense, but for the other sort of, you know, application of force, there could be, of course, other specifications.
Heating, you get to talk about heating and the mechanics of whether it's happening inside a container. The devices involved microwaving, radiant heat, applying the heat to an object, applying the heat to the environment of the object. But the difference between heating and boiling is that boiling is specifying some observable quality of the output, and requires, of course, modulating the heat to stay on that objective. So suddenly we've introduced objectives and jumped across to the other side of the hierarchy, process by objective. Yeah, should we, we'll take questions right away as we go through. So Matthew.
I don't want to break the flow. If you want to finish.
We'll go over a bit.
Yeah, I mean, this is actually our last slide, Matthew. So
I'll wait. Let me wait.
Okay.
But I think our last slide is very like just kind of closing. Of course, we need to define a scope. You know, you can have like thousands of terms under this. So what sort of a reasonable scope that helps us also just be sure that our, you know, our upper level classes, what do they contain? What's out of scope? Is there any conflict? But we need a scope. So it would make sense to reuse terms that are in recipes or that are in Food X2, or that terms that have been used in food descriptions in FTC. So to cover that, as far as robotic applications go, I think Damien knows a little more about this. Michaela, your input as well is great, to see if we can have one example and see how the terms fit into the ontology. Extension of the ontology, of course, by collaboration is great, but it's also good to use automated natural language processing tools to build it out. And I mean, this is interesting because when you have like a sort of a skeleton, so like a basic ontology, then natural language processing can map better, can understand like what's going on, how is the layout and the hierarchy, and of course, future work in collaboration. So, and this list is not, you know, limited.
Yeah,
okay, that's it.
Immediate actions are that we do have a list of about 12 or 15 upper level process terms and their definitions. So we're going to create well, maybe it should be a joint JFOW issue, which will list off each of those terms that we're looking for feedback on from all of you. Yeah, and the scope there is like, it's broad, so it's inviting directions to go in. And, you know, of course, decades of engineering has gone around food process ontology, process modeling. So for us, it's a learning experience to make that distinction between mechanism and objective. See that some processes have that baked into their semantics and others don't. At the higher level, you get you don't get polyhierarchy in this space, but down lower you do. Okay,
Kyle.
so Kyle, yeah.
Yeah, of course, I have a vested interest in foundation foods and FTC. And one of the things we've discussed recently, a few things is, processing versus preparation. And the sort of terms we've used historically versus what we're actually sort of worried about in foundation foods, where we're taking sort of a preparation to consider some of the processing that might be like the cooking process, right? And when we sort of analyze for foundation foods, we're sort of removing some of the preparation parts from our definitions, because the terms like cooked and boiled and whatnot aren't necessarily terms we're going to be using in foundation foods, but sort of separating out and maybe understanding that better when it comes to the what processing terms we've used versus what preparation terms we've used historically in SR, when it comes to sort of our approach at better defining these terms and better using these descriptors on foundation foods, is something we're hoping to align in the near future.
So do you have definitions on processing and preparation?
Lost your audio.
There we go. We have definitions and guidance for how we describe terms or if certain processes were used, primarily preparation. But some of these may need to sort of be re-reviewed, because I don't think they were necessarily consistent in SR. There was guidance for it. And I think for foundation foods, we want to be a little bit more consistent and potentially use something that sort of maybe defines these as they relate to the other terms as well.
So we can talk about this some more later then.
Yeah.
Okay.
Just to get my rough bearings, does that mean, for example, preparation is not thought to, is or is not thought to influence the nutritional content of the food? Why are you like getting?
Oh, so we actually, I could go into a full thing on this, but foundation foods were very focused on the sort of raw version of the food or uncooked in, that sort of definitions and issues we've had, Damien, as you know, as far as what we sort of have used as raw as a definition, where it may be uncooked was sort of a better word to use. And it's just sort of like distinguishing how we've used those words in the past versus how we should be using them in the future and how we should be describing these. There'll be in foundation foods, we're focused less on the preparation. We're focused less on the cooked version of the nutrients. They will change, of course, but they won't be foundation food data. They'll be more experimental food data, which will bring in sort of the additional context of how the process was performed, right? It was this cooking process was, here's the details with the amount of time they were cooked, the heat of the oven, etc. When it comes to foundation foods, there still might be other terms like we have applesauce in there, right? Applesauce was a process to get to applesauce. We're trying to focus more on the raw individual sort of apple, but that doesn't mean that some processing is always going to occur between the farm and the market. And these sort of different levels, I would say we don't quite understand the full sort of nutrient composition impact on those processing. So getting an idea and defining the terms that we're using and what we know about them, I think are going to be very important for ongoing research on processing's impact on food composition.
Gotcha. Yeah, looking forward to aligning closely. Yeah.
Mm-hmm.
In Food On, we're thinking about ditching raw for uncooked as well. Okay, next up, I think by order, Magali.
Thank you. Thank you, Tarini. This was a nice update of the work, the huge work you done with Damien. And just wondering what you meant by change is happening in the top level to link to OB. How do you link to OB actually? You plan to change something in the classes?
I think Damien can answer that. Yeah.
Yes. I'm just curious to know the link to plant process.
Right.
Because
so
it is
at the moment,
special kind, as you mentioned that RoboFoundry is more focusing on life sciences. This is a special kind of modeling or plant process. So that's why I'm very curious.
Right. So at the moment, OB, Ontology for Biomedical Investigations, spearheaded the development of devices and of the planned process concept that sits under BFO process. Planned process just being a process that has some kind of SOP, some kind of protocol to achieve, or a plan. And so the spirit of RoboFoundry is to reuse existing terms and then figure out where your work fits under them. And that's why, if Tarini, if you just go to that first slide, that's why at the moment our two new classes would fit under there. And material processing is what we're about, but there's also information processing, algorithms, and data processing. And that's why we kind of had to be explicit about the material part. The change is happening is just an invite to think about the why and the how of that change is happening. That's all. Okay, Matthew.
Thanks. Great work, you guys. I'm super excited to see this coming along. It's totally awesome. I think I had a question about the second to last slide. I think you said there was one slide left when I initially put my hand up. Actually, that one's great. So this one, I'm a little, when you say by mechanism, you've got material processing by mechanism. So when you say the change is happening as sort of that relation, that's what exactly does that mean, that material processing one, as opposed to the by mechanism?
Yeah, material processing just in the OB, I forget what the definition is offhand, but all it means is you're doing stuff to material and you're changing it. It's a really general term. It doesn't say why you're doing it or how you're doing it in that OB term itself. So now we have to get into the business of either that we've got a process that has connected to it objectives. In that case, we're going on the one side, but if there are no objectives, and in fact, it's just something like apply heat, there's no endpoint to that. There's no time when that's finished. It's just applying heat. And so that means you've stripped off all objectives. There's no stopping. There's no point at which you judge when you've finished this process correctly. And that,
okay.
No, you've stripped down to just the mechanism.
So it's semantics, I would say maybe instead of applying heat, we might want to talk about altering enthalpy. Just so we're more sort of correct from a physics point of view, that we're changing the enthalpy as opposed to applying heat, because there could be lots of ways to change enthalpy that don't involve changing the heat, and also potentially changing the entropy of the state of the matter. Just as to sort of drill down from that level. I know that food cooks don't talk in terms of enthalpy and entropy, but to be able to say that a heating process actually changes the enthalpy of the material that you're working on might be a good approach that would potentially have consequences down the road, especially with automated systems and things like that, that aren't necessarily speaking the language of a chef.
We've thought about that, yeah. We've thought about what is flux. And when you think from this sort of kind of quantum level, of course, there is change of enthalpy and entropy. So we've considered that at a mechanistic level, and when I say mechanistic, like food matrix mechanistic level, what is the change in energy state of the food? So we've thought about that as well. and at the same time, how you achieve that change in like enthalpy, right? There's a kind of force in the system, and that force can be like energy, that can be ultrasound. You can change the entropy or the enthalpy that way,
Yeah,
right? So that
so
that is, so we've thought about that actually also quite a lot, and I think both concepts are important. Like, are you applying a kind of force? Does it have a sort of direction? Is it a thermal energy?
Yeah.
And then there is that change. So yes, we've thought about it.
Oh, that's great. Yeah, the application of energy would be a sort of the parent class, maybe between the material processing by mechanism and the application of thermal energy, which would be one kind of energy.
Yeah, we've thought about that. Yeah.
And then I did want to highlight for you guys. In fact, I'll just put the link in the chat. That we did outline a bunch of food processing processes that could maybe not instantiate, but subclass some of these processing things that you have here.
Yeah, if this is what you did at IC Foods and UC Davis, Matthew.
Yeah, exactly. Yeah. So it's old, but I think it probably will slot into some of what you have here. I don't.
Yeah, but there was quite a flat list. It wasn't sort of a hierarchy. So it's interesting. Of course, we want to look at, for instance, like food X2 and, you know, the terms used in FTC. It's kind of important to look at what's out there, you know, reuse as much as possible, really consider how it fits into a hierarchy. And we're working with like material that already exists. So yeah, it makes sense.
Cool.
Hi, this is Naomi. I'm going to have to drop off for another meeting, but this was very interesting for both presentations. Thanks very much. I do want to drop in the question of what is meant by process, right? Again, because we've talked about this before, and sometimes from an agricultural point of view, processing begins with just washing it.
Yep.
Yeah.
And so, you know, how all of that fits in would be very important.
Yeah, so we collected actually a bunch of like lots of terms, and we've like in this bottom-up approach, and like a lot of washing and rinsing. There's like lots of terms like that. So yeah, no, but it's good you're saying this, but we did a lot. Like when I say bottom up, this is what we did. Like I opened all my recipe books at home, collected lots and lots of terms, and tried to think about this. Yeah.
Okay, thanks. I have to go. But
Okay.
nice seeing everyone or hearing from everyone.
Right. There's one branch we didn't show, which is the contextual change around.
Yeah.
It. So I think that's washing sounds like it fits in there a bit. Okay. Anybody else happy, ready to comment? Otherwise, I will send out a link to the group with the video, and as well a link to the issue where all of the terms and definitions we've got need feedback. Okay, great. Let's call it a wrap, and thank you all for attending. Wow, how interesting. And thanks, Michaela. That was wonderful.
Thank you.
Thank you.
All right.
Bye.